To create our standard spiral wound membranes, we construct the flat sheet membrane using Hydronautics automated casting equipment. We begin the process with a fabric support base and then coat it with a microporous polysulfone layer. This provides additional support for the top 0.2 micron thick membrane barrier layer. This top barrier layer makes the actual separation to purify the water. The semi-permeable polyamide layer consists of a thin film of polymeric material a few thousand angstroms thick, formed on a porous supporting material. The semi-permeable membrane skin is formed on the polysulfone substrate by interfacial polymerization of monomers containing amine and carboxylic acid chloride functional groups. Hydronautics manufacturing procedure enables independent optimization of the distinct properties of the membrane support and salt-rejecting skin. The combination of these three layers makes a durable membrane flat sheet that is used in each spiral wound element. The membrane flat sheet is then combined with a sheet of feed channel spacer. This provides turbulence and creates space between the membrane sheets to allow uniform flow of the water to the entire membrane surface. The leaves of membrane and feed channel spacer are then combined with a sheet of permeate spacer, which provides open flow channels for the permeate even under high pressure. The leaves are glued along each of the three exposed sides and then rolled around the core tube. With the back of the membrane completely sealed to the edges of the permeate spacer, the feed water is forced through the feed channel spacer, contacting the front or barrier layer of the membrane. Clean water, or permeate, passes through the membrane surface into the permeate channel and then flows in a spiral direction to the center of the element and is collected into the core tube. Hydronautics spiral wound elements can then be loaded into pressure vessels and interconnected with additional elements to complete any number of design specifications. Once the end adapter is connected to the last element and the pressure vessel is sealed, feed water can be introduced and then treated. The feed water that does not permeate through the membrane becomes enriched in salts as it travels through the feed channel spacer due to permeate water being removed. Typically 8 to 10% of the water is removed in one 40-inch long membrane element. The permeate water then flows out the end of the vessel and is collected as the product. And the reject or concentrate from that vessel may then flow through another vessel producing more permeate. The remaining concentrate may then be disposed of as waste or partially recycled as the feed. Typically 70 to 90% of the water can be recovered as pure product water.